Imagine looking up at the night sky and realizing that something invisible is slowly approaching our solar system. Not a comet, not an asteroid, not even a rogue planet, but a wandering black hole, a cosmic object so dense that its gravity bends space and time itself. It wouldn't shine, it wouldn't explode, and it wouldn't make a sound. For years, maybe even centuries, it could drift silently through the darkness of space before we ever noticed it. And when we finally did, the question wouldn't be what it is. The real question would be, what happens to our solar system when gravity itself begins to change? Black holes are born from the collapse of massive stars. When a star, many times larger than our sun, runs out of fuel, gravity crushes its core inward until the matter becomes incredibly dense. The result is a singularity, surrounded by a boundary called the event horizon, the point beyond which nothing can escape. Despite their reputation, black holes are not cosmic vacuum cleaners. They don't roam the universe, swallowing everything around them. In fact, if our sun were magically replaced by a black hole of the same mass, the planets would continue orbiting, almost exactly as they do today. The gravitational pull would remain the same, but a moving black hole entering the solar system would create a very different situation. Our solar system is a delicate gravitational structure. The sun holds everything together, while the planets maintain stable paths that have existed for billions of years. Introducing another massive object would disturb that balance. The first effects would likely appear in the outer regions of the solar system, where gravity from the sun is already weaker. Objects in the Kuiper Belt and the distant Oort cloud could begin to shift as the black hole's gravity tugs on them. Comets that normally take millions of years to approach the inner solar system could suddenly be redirected. Some might be flung outward into interstellar space. Others could begin falling toward the sun. Astronomers would notice strange patterns in the movement of distant objects long before the black hole became visible in any way. And even then, we wouldn't see the black hole itself. Instead, scientists would detect something even stranger: gravitational lensing. As the black hole moves across the sky, its immense gravity would bend the light of distant stars behind it. Stars would appear slightly distorted, stretched, or shifted from their true positions. To telescopes, it would look as if the fabric of space itself were briefly warping. As the black hole continued its journey inward, the orbits of the outer planets might begin to change. Neptune and Uranus could experience subtle shifts in their paths. Their orbits might stretch into elongated shapes rather than perfect ellipses. Saturn and Jupiter, the massive gas giants, would resist these changes more strongly due to their own gravitational influence. But even they could experience slight disturbances over long periods of time. Fortunately, space is unimaginably vast. Even if a black hole passed through our solar system, the chances of it coming extremely close to Earth are extraordinarily small. Most likely, it would pass through the distant outskirts, subtly rearranging the paths of small icy bodies and distant debris. To human observers, the process might unfold slowly across thousands of years, almost like watching a cosmic ballet. Planets shifting slightly, comets appearing from unexpected directions, and the stars themselves bending as gravity warps the light, traveling across the galaxy. Eventually, the black hole would continue on its path leaving the solar system behind. But the gravitational disturbance it created could take millions of years to fully settle. New comet paths, altered planetary orbits, a solar system that looks almost the same, but not quite. Our galaxy, the Milky Way, may contain tens of millions of wandering black holes, silent remnants of ancient stars, drifting through the darkness between solar systems. Most of them are impossible to see. They reveal themselves only through their gravitational effects. Right now, countless invisible objects may already be moving through our region of the galaxy. So the real question isn't just, what would happen if a black hole entered our solar system? The deeper question is, how many of these invisible giants have already passed nearby without us ever noticing?